This is the next in a series of tutorials on looking at enhanced irrigation devices to determine whether they actually do what they claim to do and to try to discern under what conditions do they do it. Thus far, we've looked at the biomineralization process and specimen preparation issues involved in image interpretation. And now we're going to look at some control cases to establish a baseline image inventory in our long-term memory bank. If you have followed these tutorials, then you're going to be able to do some real broken field running when we actually go to Dr. Pushpack's conventional instrumentation cases. So by the time we actually get to the enhanced irrigation cases, your pattern recognition skills will be fairly well developed. So we're going to compare 3 different case types as control cases that have no instrumentation, just simply water irrigation, and then water and sodium hypochlorite irrigation, and then water, sodium hypochlorite, and EDTA irrigation. Let's see if we can pick up some standardized pattern recognition for these kinds of cases. So to review, the control cases were prepared very basically from teeth in a jar, and we took teeth in a jar and sectioned them with diamond discs, splitting the 2 halves with a razor as discussed in prior tutorials. Since the teeth had been sitting in a jar for who knows how long, those pulps had undergone autolysis and could be removed easily from the tooth with little effort. After gross pulpal removal, we then irrigated with just water and a soft nylon brush. In the cases where we use bleach and EDTA, we simply placed those section halves in a beaker of the solution for the specified period of time, then dehydrated them, and then coated them and imaged them under the scanning electron microscope. Let's take them in order. First of all, no instrumentation with just water irrigation. And when you look at those cases, you get a pretty good sense of what the naked canal looks like when the pulp has been removed in the method that we used. In most places, the dentin wall looks relatively debris-free. There's no smear layer at all because no real instrumentation was done other than a nylon brush. And therefore, you can get a pretty good view of the mineralization front. And you can already see the typical collagen fiber patterns you should be familiar with now. And you should appreciate that most of the pre-dentin has been washed away, and here we were down to the level of the mineralization front. But in other areas, you can see where the pre-dentin has not been removed and is sitting on top of the mineralization front. So it gives you some correlation with what a desiccated pre-dentin tissue actually can look like. Here you can see the partial mineralization that goes on within the pre-dentin during development. And you can actually see some of the mineralizing collagen substructure that's in various stages of mineralization. And if you followed the prior tutorials, you actually know what you're looking at now. The collagen substructure and the partial mineralization of the pre-dentin on top of the mineralizing front. And when you look at the apical section of some of these teeth that have been prepared this way, you can see how the pre-dentin is partially mineralized. And since you don't actually know the status of the dentin in these cases, you have to draw some assumption that this is mineralizing dentin in the process of being formed. So this is the partial mineralization of the dentin just above the mineralization front. And here you can see the collagenous nature of the pre-dentin and the partial mineralization of those fibers. Now, with sodium hypochlorite and water cases, you can kind of gain a sense of the effect of the sodium hypochlorite. And remember, the sodium hypochlorite that we use also has sodium hydroxide in it to stabilize it. So it's going to dissolve away some of the organic material. And you should be far enough along in your understanding of the mineralization process and be asking a very simple question. What is missing in this picture? Because there is obvious gaps here. These gaps are evidence of what has been washed away by the bleach and the sodium hydroxide that's in the bleach. In other words, all of the proteoglycans and glycosaminoglycans that are present in the predentin and which actually control the mineralization process are gone. So you actually get a very incomplete picture of what is there because of the material is actually missing. And you can see the partial mineralization going on with the chalcospheroids of the predentin. You can see the collagen substructure very well here. So it's not actually the demineralization in this particular case. It's probably the stage of mineralization of the chalcospheroids. And it looks like most of the intertubular or peritubular dentin has been removed by the sodium hypochlorite. Here's another apical view, and you can see that not all of the pulp was removed in our procedures. You can see remnants of it here, as well as the partial mineralization of the predentin and the chalcospheroids that are in the process of being mineralized. So it gives you a pretty good sense of how this process continues. And that's a very good picture of the mineralization of the collagen substructure and how these chalcospheroids are actually incorporated into the finalized mineralized front of the dentin. So this should really help your pattern recognition when you see these in clinical cases. Here you can see the partial mineralization of the collagenous substructure of the predentin. This is the coronal section with bleach. In this particular case, we did use HMDS to eliminate some of the and now you gain a really good sense of the structure of the predentin, the collagenous structure of the predentin, and you should now appreciate that most of the peritubular dentin has been removed by the processing. But in other areas, you can see where the peritubular dentin has not been completely removed and is still present. So this is how dentin in the predentin actually goes through the mineralization process. There you can see we're able to image some of the peritubular dentin prior to its being removed by the irrigation method that we used. So that peritubular dentin is the non-collagenous mineralization of those proteoglycans and glycosaminoglycan that form the peritubular dentin. And now you can see these little calcification vesicles. They're 100 to 200 nanometers wide. And as these accumulate on the collagen fibers are actually being mineralized. Okay, let's take a look at bleach and EDTA cases. I think you'll gain a sense of what the combination of bleach and EDTA does to the dentin. And here you can see there's a lot of demineralization going on, and the EDTA is breaking down already mineralized predentin. And here you get a pretty good sense of the process involved. So the EDTA acts on the hydroxyapatite and demineralizes it off of the collagen substructure. So this gives you a pretty good idea of the effect of both bleach and EDTA on the substructure of the predentin, as well as the mineralization front. And here you can see the etching of the mineralization front. The predentin is completely gone here. It's been removed by the bleach and EDTA. And you're looking at the mineralization front being eroded away by the EDTA. You can see all of the peritubular dentin is gone, and you can see the collagenous structure of the dentinal tubule. So the non-collagenous part of the dentin, the peritubular dentin, is completely removed by this process. And there you can see the hydroxyapatite crystals on the collagen fiber. So I hope that gives you a pretty good sense of the pattern recognition. Next, we're going to look at Dr. Pushpak's conventional cases. And my hope is that you should be able to use some pattern recognition you've learned here and make better sense of what you are observing.